All right, let's dive into one of the biggest, most fascinating questions in AI right now. How do you get an AI to actually, to think? I'm not just talking about spitting out fast answers. I mean really reasoning through a tricky problem. It's a huge challenge, and honestly, it can be pretty frustrating. So let's get into how we're trying to teach these machines to truly reason.
So check this out. We've got two plans here for making something in Minecraft. The one on the left, it's simple, straightforward, and totally wrong. It botches some of the most basic recipes. But the one on the right, it's a super detailed, multi-step plan that is absolutely perfect. Now here's the kicker. Both of these were made by the exact same AI. So, what on earth is going on here?
The difference, it turns out, is pretty simple but also profound. One plan was just the AI's first, impulsive guess. The other was the result of giving that same AI the time and, this is key, the right tools to actually think the problem through, step by step.
And that gets us right to the heart of the problem. You see, an AI's first, quickest answer is a lot like a person's gut reaction. It might feel right, but when you're up against something complex, that kind of fast thinking can be seriously flawed.
Most standard AI models, right out of the box, are basically trained to just blurt out the most probable string of words as fast as they can. If you ask a simple question, that works great. But for a task with multiple steps, like that Minecraft plan, it just leads to all sorts of logical goofs and factual mistakes. That's exactly what happened with that first failed plan we saw.
So how in the world do we fix this? Well, the big idea, the real breakthrough here, isn't about building a totally new brain for the AI from scratch. Nope, it's about giving the AI better strategies to use the knowledge it already has. It's not about forcing it to think faster, it's about giving it the ability to think harder when a problem actually demands it.
Okay, so the fancy technical term for this whole approach is inference-time scaling. The important thing to know is that this isn't about spending months retraining a model. It's all about giving it more computational muscle and smarter strategies during the task itself, like right in the moment it's trying to solve your problem. You can think of it like giving a student some extra time at a calculator for a really tough math test.
And one of the coolest ways this works is by giving the AI something like a digital scratch pad. So when you give it a hard problem, instead of just blurting out an answer, it uses the scratch pad. It can break the problem down, it can explore different ideas, check its own work, and even go back if it realizes it made a mistake. All of that messy thinking work leads to a much, much better final answer.
All right, so what does this thinking toolbox actually look like? Well, the first tool is really incredible. It involves letting the AI think in more than just language. It's called multimodal thought. And the idea is that sometimes a picture really is worth 1,000 words. You know how you might sketch a diagram on a piece of paper to figure something out? Well, we can now let an AI do the same thing, generate and analyze images as part of its own reasoning process. Think about a tough geometry problem. A text-only AI might just get stuck in a loop, but a multimodal AI can do the digital version of drawing an extra line on the diagram, and suddenly, boom, new angles and relationships pop out, and the solution becomes almost obvious. It's literally using vision to unlock a totally new way of thinking.
And the results? They are absolutely staggering. For certain types of complex reasoning problems, giving an AI this multimodal ability can boost its accuracy by over 50 percentage points. I mean, that's not just a little bit better, that is a total game changer.
Now, the next tool in this toolbox is just as powerful. What if, right in the middle of its thinking process, an AI could just pause, look something up, and correct itself on the fly? What if it had its own built-in fact-checker?
This technique is called retrieval augmented reflection, or R for short. Just imagine a student working on a hard physics problem. They write down a step, but then they stop and think, wait a second, is that the right formula? So they grab their textbook, they double-check it, and then they continue with the correct info. R lets an AI do exactly that, but with a massive, near-infinite digital library.
So let's jump back to our Minecraft example to see this in action. The AI drafts a step, something like craft a table from wood, but then it pauses and does a quick search. It finds a document that says a crafting table needs planks, not raw wood logs. It literally catches its own mistake, reflects on it, and fixes the plan. And by doing that for every single step, it builds that flawless, perfect plan we saw at the very beginning.
So these tools seem unbelievable, right? It sounds like we just give an AI more time and more tools to think, and poof, problem solved. But is it really a magic bullet? Well, the latest research shows that the reality is a little more complicated.
Take a look at this chart. It shows how the best AI models perform across a whole bunch of really hard reasoning tasks. Everything from math competitions to tricky spatial reasoning puzzles. And what you can see immediately is that there is no single AI that's the best at everything. The performance is all over the map. A model that crushes it at math might totally fail at simple planning, which shows that these new reasoning skills don't always carry over perfectly.
And this challenge of efficiency gets really stark when you look at the raw numbers. In a recent math competition for high schoolers, 2 different AI models got almost the exact same score. Pretty impressive, right? But now look at the token cost. That's basically a measure of how much computational energy it took. Model A used 5 times more energy to get basically the same result. So thinking more doesn't just cost time, it can cost a ton of energy.
And the researchers who did this study, they summed it up perfectly. They said that just throwing more computation, more thinking time at a problem isn't the whole solution. The quality and the efficiency of that thinking matter just as much, maybe even more.
So, where does all of this leave us? What does this mean for the future of AI and where we go from here?
Well, here are the big takeaways. First, it's clear there's no single magic bullet. The future is all about giving AIs a really sophisticated toolbox, full of different reasoning strategies, like thinking in pictures and using fact checkers. But the real challenge is going to be teaching the AI to know which tool to pull out for which problem. And finally, the next huge frontier is efficiency. How do you get the right answer without, boiling the oceans?
And all of this leaves us with one final, pretty provocative question. As these AIs get better and better at thinking for themselves, using these complex, autonomous toolboxes we're building for them, how do we keep up? How do we make sure that we can still understand their logic, that we can trust their answers, and verify that their reasoning is actually sound? That's a huge challenge, and it's not just for computer scientists, it's for all of us. Thanks for tuning in.